Hi guys, welcome back to Calculus with Mr. Robeson. The second half of basic derivative rules, we're going to look at the sum and difference rules, and we're going to look at the rules for derivatives for sine and cosine. Then we're going to apply this a little bit for rate of change. All right, so sum and difference rules are very straightforward. If we're adding together two functions and we want to take their derivatives, we just take the derivative of each one. Same with if we're subtracting two functions, we just take the derivative of each one and we're subtracting the difference. All right, so that gives us derivatives of any sort of polynomials now that we've worked with. So we can take the derivative of this first guy here, and I don't think I'm gonna have room over here. So let's try this guy, say, down here. So if we want to take the derivative of that guy, f prime of x, first we take the derivative of x to the third, so we bring down the 3, x to the 1 less exponent, so squared. Now we're doing our difference rule, so minus. Now we're doing the derivative of 4x. So this is 4x to the first. So we have 4 still. We bring down the 1. X to the 1 less power would be 0. Plus, now we're using the sum rule. Derivative of 5 is 0. 5 is just a constant. So we simplify this. We're going to get 3x squared minus 4. Because x to the 0 is just 1. So 4 times 1 is just 4. So there's that guy. All right, if you want to go straight to this answer when you're taking the derivative, you can. That's fine. Next one. All right, so we got negative x to the fourth over 2 here. Let's try and rewrite that before we take its derivative. So I'm going to rewrite that as negative 1/2 times x to the fourth plus 3 times x to the third minus 2 times x to the first. And now we take the derivative. So dy over dx is, we bring down the 4, so we get negative 1/2 times 4x to the third, 1 less exponent from 4 is 3, plus 3 times, bring down the 3 here, 1 less exponent is squared, minus 2 times 1x to the 0, which is just 1. All right, so we get that our derivative is negative 1/2 of 4 is negative 2x to the third, 3 times 3, so plus 9x squared minus 2 times 1, so minus 2, and there's our answer. All right, derivative rules for sine and cosine. So the derivative of sine is just cosine. Derivative of cosine is negative sine. The way I like to remember this is by looking at the graphs. So sine, remember, looks something like that. So right here, the slope is positive. Right? It's going up. So this was the graph of y equals sine of x. And I know they just go back and forth between each other, and we want positive, so the derivative is positive cosine. Right? If we want to go the other way, cosine starts up here and then comes down. So it starts off being 0, and then it becomes a negative slope. And that's why we get negative sine, because the slope is going to go down. It needs to be negative. That's why we make it negative sine. So cosine goes to negative sine goes to positive cosine. So let's take a look at some examples. So the first one, y equals 2 sine of x. So the constant rule still applies. We still have times 2. So dy dx, the 2 stays out front. Derivative of sine says is just cosine. So 2 cosine of x. Done. All right, the next one, we can rewrite this. Again, constant rule. We can rewrite this as 1/3 sine of x. Now we take the derivative. F prime of x is, well, 1/3 stays there. Derivative of sine is cosine, positive cosine, so this just becomes cosine. So we get 1/3 cosine of x, or 1/3 times cosine of x. All right, here we're using a sum rule. So derivative of g is g prime. Derivative of x is just 1. Derivative of cosine is negative sine. So instead of saying plus negative sine, I'm just going to say that this is minus sine of x. And there's our answer. All right, well, how about you try one now? So s of t is 2t minus cosine of t. We switch the variable. No difference. Take the derivative the exact same way. If you need more time, go ahead and pause it. So I'm going to write the 1 there. So the derivative of 2t is just 2. So s prime of t is 2 minus the derivative of cosine. Well, remember, cosine starts up, and then it's coming down, so it needs to be negative. So derivative of cosine is negative sine. Our variable is t, though, instead of x, so negative sine of t. So minus a negative gives us plus sine of t. So 2 plus sine of t, and there it is, 2 plus sine of t. All right, another application here, or working towards another application. So the derivative finds the slope at a point for a function. If the function is positive, or sorry, the function is the position, so where something is located, not positive, where it's located, its position, like how high up or how far over, then the derivative is the velocity, which is how fast something is going. It's its rate. All right, so rate is distance divided by time. So if we want the average velocity, we can get the change in position over the change in time. All right, we often use the letter s for position equation. So often we'll use s of t or h of t for height. S would be position. Sometimes we'll use y of t or y of x. All right, so those are what we usually use for position functions. So if I use s here, it'd be the position at time b minus the position at time a over b minus a, the difference in the time. So this would be the average velocity from a to b, if s of t is my position. All right, so let's look over here at an example. A ball is dropped from a height of 100 feet. Let's make it more fun. You're dropping a water balloon. You're trying to hit your friend below 100 feet below. That might hurt. Its height s at time t is given by the position function s of t equals negative 16t squared plus 100. Get used to seeing this negative 16t squared. There's a reason for it. Where s is measured in feet and t is measured in seconds. So there's our units right there. Always have units in your answer if they give you units. Find the average velocity over each time interval. So average velocity, that's right here. So we want the position in the end minus the position in the beginning divided by the difference in time, how long it takes to get there. So the average velocity here will be s of 2 minus s of 1 over 2 minus 1. So the position at time 2 is negative 16 times 2 squared plus 100 minus the position at time 1 is negative 16 times 1 squared plus 100. And then this is all over 2 minus 1, which is actually just 1. So we get negative 16 times 4 is negative 64 plus 100 minus negative 16 times 1 is just negative 16 plus 100. All right, there's a couple different ways we could do this. We could do what's inside the parentheses first, or we could probably cancel out the 100s. I'm just going to do that. So we get negative 64 plus 100 plus 16 minus 100. The hundreds are going to cancel out. I just distributed this negative sign here. We get negative 64 plus 16 is going to be negative 48. The units on the top here were feet. Units on the bottom here were second. So this answer is in feet per second. All right, so the answer here is negative. Well, the ball was dropped. So that means it should be going down. So a negative answer means it's going down. If it was positive, that means it would be going up. So from 1 to 2 seconds, it is going down at 48 feet per second. How fast is that? Probably not fast enough to kill anybody. So we're okay at this point. All right, now if we get we make our interval a little bit smaller. We would do s of 1.5 minus s of 1 over 1.5 minus 1. And we could work that out just like before. All right, same thing here. From 1 to 1.1, we would do s of 1.1 minus s of 1 over 1.1 minus 1. All right. And as this interval gets smaller and smaller, we get closer and closer to the rate of change at exactly 1, which is the derivative at exactly 1. So let's look at that. All right, so velocity and the derivative. So if the position function is given with time as the variable, then the derivative of position is velocity. So if we're taking the derivative of position, we get the velocity function. All right, so we usually use v for velocity. If we're using s for position, that means we've got the derivative of position. So our position function here is s of t. And this is just our limit definition, which is what we were just doing before. S of t plus some extra delta t minus s of t, the starting t, divided by the difference in the t's. That's exactly what we're doing on the other page. All right. Position of an object under the influence of gravity. So only gravity. Here is our gravitational constant right there. If we are working with feet, then g equals negative 32 feet per second squared. In acceleration, we have seconds squared on the bottom. If we are working in meters, g is equal to negative 9.8 meters per second squared. Sometimes we'll just use negative 10, so that's pretty close enough. V0, that is our starting velocity. So if it's thrown up or out, or it's up or down or whatever, that's the starting velocity. And then finally, this s sub 0, this is our starting position. All right, so we can build up an equation if we're just given these information. We just fill in the numbers here. We do have a 1/2 out in front of the g. We'll get reasons for that later. But we have the 1/2 gt squared plus the initial velocity or the starting velocity times t plus the initial position or the starting position, and that's our position equation. If we hear that something is dropped, that means the velocity to start is 0. So like if we drop something from a certain height, it will have that starting height. This term will just cancel out. It will go away. Let's take a look at an example here. All right, so at time t equals 0, a diver jumps up. So they're starting off by going up from a platform that is 32 feet above the water. So there's our 32 feet. That looks like an initial height right there. The position of the diver is given by s of t is negative 16t squared plus 16t plus 32. All right, so this 32 is our initial height. This negative 16 comes from negative 1/2 times, 1/2 times negative 32, our g, because we're working in feet. And this must be their initial velocity. Your starting velocity is 16. Where s is measured in feet and t is measured in seconds. Always a good idea to underline your units. When does the diver hit the water? All right, so the trick is when it hits the water, the height is 0. So we want to know, when does s of t equal 0? So we just set this whole function equal to 0, and we're going back to algebra 2 here. All right. To solve this, it's quadratic. We need to factor out this negative 16. So we'll pull that out. We'll be left with t squared. If we divide this by negative 16, we're going to negative 1t, and we're going to get negative 2. So negative 16, this will factor into t minus t plus. Factors of 2 that subtract to make 1 are 2 and 1. And if we're setting that equal to 0 still, we just set each one of these equal to 0. We get t equals 2, t equals negative 1, and these are both in seconds. I guess we already used s before, so I'm going to write SEC. All right, now, does it make sense that we've gone backwards in time? Probably not, unless you're Marty McFly. All right, but that means if instead of going up, if they went straight down to begin with, that's when they would hit the water backwards. All right, so the answer we want is going forward in time. So 2 seconds is how long it's going to take. Now that we know the time it takes, what is the velocity when the diver hits the ground? So that means we want to, or sorry, hits the water. We're diving into water, I hope. So we want v of 2. So we got to find v of t, which is the derivative of the position. So we want to take the derivative of this guy. So that's going to be negative 16 times 2t plus 16. Derivative of t is just going to be 1. And the derivative of 32 is 0. So we get negative 32t plus 16. This negative 32t is pretty common. There's our v of t. to find v of 2. Now we're plugging in 2. Negative 32 times 2 plus 16 is negative 64 plus 16 gives us negative 48. It's a velocity. We were working in feet. So that means this is feet per second is going to be our velocity. And there's our answer. All right. So that's it for this section. So we looked at the sum and difference. So if we're adding or subtracting between different parts of functions or any polynomials, we can take our derivatives. We can take derivative of sine, it's just cosine. Derivative of cosine is negative sine. And we looked at application for rate of change in average velocity. All right, that's it for 2.2. So check out the homework assignment on Google Classroom.